nhau.
Nhưng mà phát lên nó đổi màn hình đấy.
Như nhau.
Được.
Không đủ.
So welcome you guys to our presentation. Our presentation. So our group, our so we are working on the gas level sensor and the display system. So this is our team member. So have you ever think about being a chef in a kitchen? Maybe in a food restaurant, then you will know that when you use the gas, maybe using the gas is more efficiently and less cost. And so I will start again. Have you ever thinking about being in the kitchen or maybe being a chef in a restaurant? A restaurant, then you will know that being using gas. Bị mất à? Đây lên rồi. Em cảm ơn. Rồi. Okay, so I will. So gas leak is a common cause of fire accident and explosion in home, industry, or maybe you know a lot about the restaurant. And many incidents occur due to the absence of early gas leak detection system. And we need a solution to detect and fix this efficiently. So we will introduce you guys to the gas level sensor and the display system of our group. So in overview, this is a smart IoT system that monitors and warns of the gas leak, contributing to protecting human safety in living and working space. So these are some of the main functions of the system. That is detect and display gas concentration in real time, warn user on site without image when exceeding safety threshold, and then send data to the smartphone via Blink application for remote warning. And we can it can be applied in environments such as kitchen, gas storage, or laboratory. So our objective of the objective of this project, that is detect gas leak using MQ6 sensor, alert user via buzzer and LCD, and also send real-time data to the Blink app via Wi-Fi. We are using ESP32 for this, and maybe in the larger space, then we can apply this for home safety automation. So these are our design steps. The first, we will determine the product specification. The second, we will design the block diagram. Third, we will making the hardware. It's about collect component, draw electric schematic, and make the circuits. For to the next, we will making the software, like design flowchart and algorithm. Upload the code using Arduino IDE and also connect to the Blink server. As the final, we will test and troubleshoot the problem we made. Không được rồi. Đã chết rồi. Vừa mới chỉnh được nữa. Chập chờn à?
Trời.
Và chúng ta làm slide đi đến cái tỷ số như vậy chiều 6 em và em sẽ nghe xem.
So this our product specification. So we will using SP32. As I have said, the gas sensor we will use that is MQ6. The display we will use LCD to I2C interface. We have a buzzer and a Blink IoT platform for this. And we also use a Blink smartphone app as you can check on App Store and Google Play. We will use a power supply of 5V, 5 volt. That we will supply from the computer. Forget it. So the input we will have that is the analog gas concentration from MQ6, and the output signal that is from the buzzer, the LCD display, and the LED on blink. The warning threshold we will custom encode. For example, in this, we will use 50% for the threshold. The update speed we will do that is 1 time per second. And there are some smart function like send event to the cloud, automatically reset alert if it's set again.
We use the following components: ESP32, MQ6 gas sensor, LCD 16:2 with I2C, active further jumper wise, and a breadboard for prototyping.
Không nghe thấy đâu. Không nghe đâu.
Nhưng mà cái này không nghe được.
Kể cả vậy không nghe thấy.
Nói to lên, không nghe thấy.
These are micro controller with sensor data, control the outputs and connect to Blink via Wi-Fi. It detects LPG and methane gas. Its analog signal is sent to the ESP32 for processing. This displays the gas level and system status connect via I2C for simpler wiring. This is our system block diagram. Input in cloud. The gas sensor ESP32 acts as the processor.
Bảo nó chưa, cái màn hình PowerPoint nó là một màn hình khác, không phải là cái màn hình gì đâu.
Thấy không? Thế thì để em share lại. Rút ra đi. Máy nữa này không là máy số phân. Thì mình nghĩ qua đây là nghe được.
Đúng rồi. Có bạn thì coi thay đều ạ. Có thay đều. Còn thì tao thay đều nó khó. Có thay đều mà. Không có gì đâu. Cứ tiếp tục đi. Thực ra tiếp tục ở bên ngoài.
Lắc nhau rồi không? These are our system block diagram. Input includes the gas sensor, ESP acts as the processor, output as the LCD buzzer, and the Blink app. These are the full circuit schematic. The MQ6 sensor connect AO to GPIO 34 on the ESP32. VCC to VINs, ZND to ZND. The buzzer is connected to GPIO to ZND. The LCD I2C module is quite quick. SDA to GPIO 21 and SCL to GPIO 22. VCC to VINs and ZND to ZND. All components are linked to the ESP32 for data reading, warning signal, and display output. And in this slide, I will show you how to Blink protocol work. And the first, ESP32 connect to the router via Wi-Fi and get a local IP address. Just TCP/IP connection to Blink Cloud and connect to the Blink Cloud using cross AT. After that, it will send data via TCP. When that level changes, ESP32 send a data in JSON or Blink binary from us to the server through a TCP packet, and Blink servers respond the data updates the Blink apps in real time. And now I will in this year follow of the data. First data sent to application layers. This layer is the highest layer where the Blink application operates. And second is transport layer. TCP protocol ensures that data is sent correctly and completely. Using TCP protocol, this is the layer that ensures data is not lost. And third, network layers. Instead, data packets go from the IP address of the ESP32 to the IP address of the Blink servers on the internet. And so last, data link layer. This is the loose layer performing the physical wireless connection between the ESP32 and the Wi-Fi routers. And here is the visual interface of the Blink applications and IoT platforms, the allow remote monitoring and control of the device over the internet, your smartphone and computer. This platform, this is phones app interface, display real-time gas sensor values and warning when the gas level is dangerous around more 50. And middle frame sit in notifications sent by the ESP32 to the Blink cloud, and the Blink forwards is the phone when the danger detects. And last in right frames is the Blink web controllers that are similar to the phone, allowing user to manage the device from computers. And now I will present the flowchart of our gas detections and alarm system using ESP32, MQ6 sensor, LCD, buzzer, and Blink app. The process will begin with initializing all the necessary components, include serial monitor, Blink, LCD, buzzer, and a timer that runs every 1 second. After a short system running system.
Có còn attendant đúng không? Em thử lên the pointer. Thì vào em phải làm sao để thu hoạch sự với mọi người nhé. Tiếp tục em.
The process begin with initializing all the necessary components, include serial, Blink, LCD, buzzer, and the timer every 1 second. I haven't changed it yet. After a short system loading display on the LCD, and we check for the Blink connections. If it not connects, the system will attempt to reconnect automatically. And once connect, the system will continuously read analog value from the MQ6 gas sensor. We must notice that the MQ6 is an analog gas sensor and it had an analog output. It changes the output voltage depend on the gas concentrations around the sensor and changing the resistance inside the sensor. When the flammable gas such as LPGs or propane or butane come into the contact with the sensor surface, the semiconductor component in MQ6 will change its resistance and also changing the analog output voltage. And the ESP32 read the analog signal from the MQ6 and it had ADC, it was the analog to digital converter pins to read the analog voltage from the AO pin of the MQ6. And this analog voltage will correspond to the gas concentration level. And the ESP32 will convert this analog voltage signal into digital value and usually at the 0 to 4095 with a 12-bit ADC. The voltage will map to a percentage from 0 to 100%, representing the gas concentrations. The gas level is shown on the LCD and print to the serial monitor on the computer and also update in the Blink app on both computer and mobile apps. And we have to check if the gas level is at the 50% threshold and the buzzer now activate and a notification is sent through a Blink app via email. The notifications is only sent once per high gas event to avoid the spamming. When the gas level drops below the threshold again, and the buzzer will turn off here. And the alert state is reset. This ensures a continuous real-time monitoring loop with clear alert and safety response. And here's the algorithms of our system. It's the same with the flow chart. Yes, initialize the component and connect the Wi-Fi and the blind server, and it's a main loop of our system. Read the analog, then convert the raw value to percentage, and also display the gas level and status on the LCD, send the gas level to Blink app. And next, we will check the gas level threshold. We set the threshold at 50%, and if the gas level is higher than 50%, it will activate the buzzer and also send the notifications and email, or it will deactivate the buzzer and it will repeat the loop every 1 second. And we will create and compile the code and upload using the Arduino IDE. And here's the code. There's a part we convert the signal to percentage. And here's the final products of our group. We have the video to demonstrate the activity of the system. This video have the sound. When the sensor detects the gas, we will send the notice to the mobile phone and update to the Blink app on website and send the email. After the test, we can conclude that the NQ6 is successfully detects the gas level, and the gas level is displayed on the LCD screen, the serial monitor of Arduino IDE, and also the blink app on mobile and website. When the gas is higher than 50%, as we said, the buzzer will activate and mobile and email notifications is sent. And it's sent once per high gas period. Now let me summarize the strengths and the limitations of our gas detection system. At the strength side, the NQ6 sensor reliably detects the several gas, include LPG, the butane, propane, methane, alcohol, and hydrogens. It has multi-platform monitoring like LCD serial monitor and also the blink app. And it emits the alert through a buzzer by mobile push or email. And it's very user-friendly interface on blink app. But also it has some limitations that it cannot detect the toxic gas like CO or carbon dioxide because of the sensor. The NQ6 sensor can only detect those gas, and the detection range is kind of short. I think so. And it also cannot identify the specific gas type, only the concentration level, just level, not the type of the gas. And the NQ6 is affected by the temperature and the humidity. And the optimal conditions of the NQ6 sensor is about 20 to 30 degrees Celsius and lower than 60 humidity. And lately, the sensor requires a warm-up period to stabilize before providing the reliable reading. And for the future improvement, we plan to several hardware upgrades. First, we want to replace the NQ6 sensor with something that more effective, like NQ135 multi-gas sensor to detect also the carbon dioxide, nitro-3 hydrogen, and smoke. And add the DHT11 module to measure the temperature and humidity to severe overall environment warning. And some rechargeable battery for continuous operations, not just about the USB connect. And add a relay module to automatically turn on extra fan when warnings occurs. And also we want to expand the IoT connectivity, not just about the Bing app. We can write the data to Google Flight Base or ThinkSpeed or Blink Count or something. And we want to integrate it with a real smart home. And we can improve the user interface and add some button or something like that about the graph, measurement history, and also the attach and combine our system with some applications like monitoring dormitories, the kitchens, or air conditioning room, and also the applications in industrial zone with batteries. And thank you for listening. Thank you for listening. Yeah.
It makes something difficult for you. So anyway, can you show the product?
Yeah, here's my products. We can mở lên, mở app lên. Nối mạng không? Rồi của 13%. Là cắm là nó chạy ấy. Em mới dùng bật lửa. Có app với cả app ở trên điện thoại với cả cái hiện tại còn đây là monitor có cả mail, còn cái này là serial monitor của computer.
khi mà bọn em lấy có khí, cái này chỉ phát hiện khí ga thôi, chỉ cần dơ khí vào rồi thì cái này nó cần khoảng 1 phút để nóng lên, và em đã trình bày ở trong cái phải chống lúc nó nóng lên thì nó mới đúng được.
Tức là em gửi cả mail gì?
Nó như cả mail.
Nó kêu đấy là nó sẽ gửi thông báo vào mail. Còn mức thì nó sẽ chuyển qua phần trăm, cao nhất là phần trăm.
Nó mặt kém.
Báo nó cũng hơi lỗi.
Thực ra nếu mà cho cái này nó chạy liên tục thì nó sẽ được một cái biểu đồ nữa ở dưới, nhưng mà tại vì là bọn em cũng chỉ chạy được có khoảng 1 phút. 1 phút là test dữ liệu các thứ thì bọn em cũng không có được cái biểu đồ, tại vì ít quá nó không có thống kê. Thế nên là nếu mà cái này mà cắm điện liên tục với cả mua gói premium của tấm này
Để mua gói premium
Tức là cái app này là mình gọi là mình đang dùng miễn phí đúng không? Nó kiểu nó hỗ trợ các em khai báo đúng không?
thì nó
Nếu mong muốn ảnh hưởng tức mình
riêng.
thì đó mình sẽ dùng không đúng không?
Cái server thì nó cũng không
server hơi khó.
hơi khó đấy.
Thôi rồi, ok, đánh giá tốt nhé. Bạn có muốn lên sang không?
Có bạn vừa lên xem.
Có. Thế được rồi.
Tại vì đang để phải là 1 phút một message.
Cái message là 1 phút một cái. Còn đấy, từ phải chờ 1 phút đã, tại vì chờ 1 phút mới gửi một lần, không thì bị hết gói premium mất. Hết gói free.
Link thôi.
Tao đã hiểu.
Em là nhóm thứ 2 thì dưới lên ấy.
Cái ga level là nó là mức độ đầu ấy.
Độ 50 thì nó mới cảnh báo. Đến mức 50 thì nó mới cảnh báo.
Đâu còn đâu.
Đây.
Không được ở đây vậy.
Không phải châm ga thôi.
Đúng không?
Đúng rồi, châm ga rồi. Cân máu.
Mà bạn giữ cái nút kia để hát cái ga.
Mình anh em không dùng vật liệu bao giờ. Đây chỉ đây thôi.
Ok ok.
Thế kiểu nghỉ qua một lần xong là hết cái đợt đấy đi thì nó set lại, xong rồi nó mới gửi.
Cao nhất là 100 à?
Cao nhất đã set cao nhất là 100. Và mắc được bao nhiêu cao nhất là 100.
Ôi trời ơi, tự nhiên mình chui qua đây đi bài. Đấy.
Về nhà tao lấy sạc vi tính. Nên tao không về nhà lấy sạc vi tính. Giới thiệu cho khách khách